In previous video we covered touch probe, and today we are going to show combination of touch probe and cam profile, which is flying shear on a Printmark. Immediately let's get right into it, and we start with our cam profile. So we will create a new one, add object, cam table, we'll call it shear Printmark. We go to cam table, and now we will generate our cam profile from the beginning. 60, let's say 0, this is our waiting time. Then we need to create some kind of a ramp amp with output velocity 1. Then we will move 100, let's say 260, 160, and output velocity 1. And then we go back to 0. Now we created our cam profile, and here we have synchronized phase between 160 and 260 on a master. And we have also this, I would like to call it a working area, which we already mentioned in flying shear. Now let's immediately go to settings of our master. And for this exercise, we will set up our master something which is much bigger than the master settings of our cam profile. Our cam profile is 360 on a master axis. Let's put here like 10,000. I will explain why. Last time on our master drive, we used IODQ set, and I would like to create a variables just that we are able to trace those two values. So let's call it IUE master DQ set. Our actual values of input is going to be Q, unsigned integer, master IO act. Now what we need to do is go to our part of the program where we initialize our flying shear. So let's now put our new flying shear Printmark, because now we are executing on a Printmark. Our cam is not going to periodic. We need to set periodic to false on MC cam table select. MC cam, it's cam table select dot periodic equals false. Let's create now our new piece of program where we will execute our Printmark cam Printmark, and let's call it in our program. So for this we do not use anymore length to cut, we do not use auto cam, and let's call it cam on Printmark and cam Printmark. Let's create our piece of program. So case I auto, we will use the same variable like in our previous auto, 0. And now what we need to do first is execute MC touch probe. So MC touch probe master dot execute equals true, and we have to increase let me create the rest of the program and then we can comment. Now this is a simple piece of program, and in fact the main point lies in this section here. So what we do is wait for a touch probe, and then to master offset on MCCamIn, we put negative value of recorded position. With this, we ensure that our 0, 0 position on our cam profile is exactly the same mechanical position where the sensor picked the print mark from our feeding material. Now, there are two problems. If, for example, I start my cam in 9900 and I know that in the middle of the cam profile, master will start a new modulo range. It will start from 0. The axis and SoftMotion will handle this, and there will be no problem when master is changing its modulo value. Second, for example, I capture position 9995, but at the moment that this position reached controller, the controller is already at position somewhere above 0, let's say 5. Now in this kind of situation, if you use this piece of code, there will be error of the MC-cam in, mainly because you cannot start the cam outside of its limits. So limits are 0 to 360 for master. At that moment, we will say 5 minus 9995, and this would be negative value as a starting position, and this could not work. So let's make a piece of code, and then I will explain. If master fset position is greater or equal to MC touch probe, so we are suggesting that master is always moving forward, execute this piece of code. If it's less than a touch probe, so we detect this edge of modulo range, then we put our master offset to 0, but then we need to push our master axis for exactly the difference between recorded position and modulo range. So now there are only two things to do. We need to easily simulate our touch probe. Let's take this button, copy paste, let's change the text, Printmark, and then variable, we say IO globals Q set, okay, and it's .2. Let's go to our trace. Now we will not use tappet because we don't have tappets on our cam profile, but we will add plc program.mc. So we added recorded position. We will use IUE master DQ set dot 2, and we will add Q act dot 0. Let's convert this to multi-channel, and that's it. Let's load our program. Now I could start with this program in certain point to make it fully automatic, but then I will waste a lot of time in our software. This I will leave it to you. So our program is loaded. Let's first enable our drives. Let's set position to a slave because we want it to start from 0, 0. Master we will not touch. Let's prepare move velocity. And because we are handling our cam in the software, we just need to execute MC cam table select. We see periodic is false. And now we can run our master. So let's say our master is running and we are feeding some material Let's download the trace. And we see master is running. Now we push our Printmark, and then on a falling edge, Printmark will trigger the touch probe and we will execute our cam profile. And again. Okay, let's see our trace. And let's stop the trace and analyze a bit. So what we need to check is our end of profile position in comparison to our recorded position. So we have to go to cursor, and if we check our end of profile and see the master position, okay, we can say that this is approximately master position equals 3937.66. So let's open the calculator. 3937. Okay, and now if we check what was the recorded position from the touch probe, which was here, $3,577. So if we say minus 3,577, we see that this is exactly our master range. So we cut it exactly and synchronized our cutting with the Printmark. That's it for this video. If you like it, please give it a thumbs up. Don't forget to subscribe, and I'll catch you in the next one. Bye.